Hello everyone, it's the Motorcycle Muse here. In this video I'm going to show you how to run some checks on the regulator rectifier in your motorcycle and also on the stator in your motorcycle using a multimeter. So why would you want to run checks on the multimeter and the stator in your motorcycle? Well, these two components play an important role in the charging system of your motorcycle. They recharge the battery. So if either of these components are not working, then your battery most likely is not going to get recharged. It's going to go flat and then your motorcycle is not going to be able to run. So if you've noticed that you have problems with your battery, it's not getting recharged, then you will obviously do a number of checks. First of all, you will check the connections at the terminals of the battery. If the connections are not good, then your battery is not going to get charged properly. You will check your earth connections. The earth connections are where the negative terminal of the battery is connected to the frame of the motorcycle. There will probably be a few earth connections around the frame of the motorcycle. It's not just going to be connected to the frame of the motorcycle at one point. You will also check the wiring loom and the wiring in general in the charging system of your motorcycle. If you determine that the wiring is all good, that you have no broken wiring, you have no wiring that's damaged, no wiring that's shorting off other wiring or off the frame, then you can conclude that most likely the culprits for the problems with your battery charging system are either going to be the regulator rectifier or the stator. So the first thing I'm going to do is I'm going to disconnect the regulator rectifier from the wiring loom. So the regulator rectifier is this component here. If you're not sure what a regulator rectifier is, then first of all, please take a look at my other videos on how a regulator rectifier works. And also I've done a video on how to check the charging system of your battery. So to disconnect the regulator rectifier from the wiring loom, we just unplug this connection here. Okay? Now, I'm going to set up my multimeter. I'm going to focus on the wiring, the connection from the wiring loom first of all. So this connection into the wiring loom connects the regulator rectifier to two components. Firstly, it connects the regulator rectifier to the battery, and then it also connects the regulator rectifier to the stator. So the first readings I want to do are on the connection into the wiring loom itself. Now, as I mentioned, the regulator rectifier is connected to the battery and also to the stator. So I should be able to find which wire is connected to the positive terminal of the battery, and I should be able to find which wire is connected to the earth or the negative terminal of the battery. So I'm going to turn on my multimeter and set it to measure direct voltage. Now, looking at the wires feeding from the wiring loom or into the wiring loom, there is 5 wires. 4 of them are black and 1 of them is white. Now, I don't know where any of these wires are connected up to, but I have a feeling that maybe if I start at the white wire, that might be the wire that is connected to the positive terminal of the battery. So I'm going to take the red terminal of my multimeter and I'm going to touch it off the little black connection in the connector. or sorry, the little white connection in the connector, like so. So if that is feeding from the positive terminal of the battery, if I connect the black connection from my multimeter to a bolt on the frame, which is going to be earthed, I should get a reading of 12.5 volts. So as you can see on the multimeter, I'm getting a reading of 12.51 volts. Now that is the same reading if I connected the red lead on the multimeter to the positive terminal of the battery and the black lead to the negative terminal of the battery. I would get a reading of 12.5 volts as well. So I now know that that white wire is the wire that is connected to the positive terminal of the battery. So the reason I want to find the positive terminal of the battery, first of all, is because I want to run continuity tests on all the other connections in the connector, on all the other wires that are feeding into the regulator rectifier. But you should never run a continuity test on a circuit where there is current flowing. Okay? So it's important that I know which wire is connected to the positive terminal of the battery to make sure that I do not run any continuity tests on that wire. Okay? Now, I can, if I want, just to be sure, I can run a continuity test on all the other wires, or I can run a voltage test to make sure that there is no voltage. So I'm just reading it here. So it's now measuring in millivolts. Okay, so this is this multimeter changes scale automatically, so it's measuring in millivolts at the moment. Now it's jumping around a little, but it's essentially 0. Okay. So there is no way that current can be flown in any of these circuits because the millivolt reading is basically 0. Okay. Okay, so all those other wires now should be safe to run a continuity test. So what is a continuity test? A continuity test, and the continuity test is run by setting the multimeter to the diode symbol. So it's a little arrow symbol on the multimeter, and what the continuity test, it essentially just measures that you have an unbroken circuit. So in an unbroken circuit, current can flow. In a broken circuit, current cannot flow. So if we connect the two leads of the multimeter together, we see that we get a reading of 0.000. That means that there is 0 resistance in this circuit, that we have an unbroken circuit. If I unconnect the two leads of the multimeter, I get a reading of 0L or OL. So I think that just means that it's out of limit, is what it really is saying. But what it essentially means is that we have a broken circuit, that no current can flow in this circuit. Okay? So again, if we have a good circuit, we get a reading of 0.000. If we have a broken circuit, we get OL. So what am I going to be testing for now? So I suspect that the pin on the bottom left of this connector feeding into the wiring loom is actually connected, is the actual earth connection. So this is the one that's connected to the negative terminal of the battery, or it's connected to the frame. Okay? So how I can check that by, again, putting my red lead of the multimeter and then into the connector, and I'm just going to touch this off the frame of the battery or frame of the motorcycle. So it's jumping around a little, but it's going down to about 0. Okay, so I can actually So I've just set it that it gives a beep on my multimeter if I have continuity. So again, I'll just do this test again. Let's see. So I'm getting a beep. That means that we have continuity. So that means that I have found the pin on my connection that is connected to the negative terminal of the battery or is earthed to the frame of the motorcycle. So what are these 3 pins on the right hand side connected to? Well, I know that the stator on, or the alternator on this motorcycle is a 3-phase alternator. So that means that the stator will have 3 wires feeding from it and feeding into the regulator rectifier. So I can assume that the 3 remaining pins from the 5, the 3 remaining pins are the 3 wires that feed into the stator. Now, if you take a look at my video on how a stator and a rotor work, you will see that inside the stator there is a number of coils or windings of copper wire, and all these copper wire windings are all connected in one circuit. So if I put one of the leads from the multimeter connect to one of the pins in the connector and connect the black lead as well. Let me get a good connection here. So it's saying that it's indicating there, that beep on my multimeter is indicating that we have continuity. So it means that we have a complete circuit, that current can flow in this circuit. And let me just try it for all 3 pins. Let's just move the leads around. So bottom, black in the bottom, red in the middle. Black in the bottom, red at the top. Let's try red in the middle, black in the top. Again, black in the bottom. Let's leave black at the top and move red around. So no matter what way I connect up the red and the black lead from the multimeter with the 3 pins on the right hand side which are connected to the stator, I get continuity. It's indicating that current can flow. And that is what I would expect. I would expect that current can flow, or that we have perfect circuits. So essentially just think about that. If I touch these off, we have a perfect circuit. So essentially what it's saying is that we have that current can flow from this black lead, or the charge can flow from the black lead through the stator, the windings in the stator, and back to the red lead. That's what that continuity reading is telling. Now, if I do these tests on the pins from the stator and I get a reading that there is no continuity, then that indicates that there is a break in the circuit, or there is a break in the wire somewhere in the stator. And that would indicate that we have a problem with the stator. So that's the continuity test that we run to check that the stator is okay. So you don't have to take the cover off. The stator is located it's on the other side of the engine, located underneath the alternator cover. So it's basically on the other side. It's around in here. To get at the stator and to check it, you would have to open the engine up. And you don't want to be doing that. So it's just a simple check that you can do. Assuming that the wiring from this lead here, or this connector, into the stator is all good, and you will check that, then you should have perfect circuit. And if you don't, then you have a problem with your stator. If you don't get the beeps, if you don't get continuity, that indicates that you might have to open up the alternator cover, possibly replace the stator. Now, the last test you want to do on the stator is you want to check that the insulation that covers the coils and wire in the stator is all good. Now, if the insulator that the coils of wire sit on and that they're covered with is bad, then the wires in the stator will be able to touch off or create a connection with the stator cover possibly, or essentially the current generated or the charge generated in the stator will be able to leak out through the stator to earth, instead of the charge coming up through the 3 pins and into your regulator rectifier and then onto your battery. So, how do we check that that the insulator covering the coils of wire in the stator is good? Well, we do more continuity tests. So in this case, I'm going to touch the red lead of the multimeter off one of the pins from the stator, and I'm going to touch that off I'm going to earth it. I'm going to try and earth it, touch it off earth. So you can see here that it's giving a reading of OL and there was no beep. Okay, so that indicates that we do not have continuity. Let's check it on this one. Again, there is no continuity. And on the third wire from the stator, again we have OL, we have no beep. Again, it's indicating that we have no continuity. That's what we want to see. We want to know that the coils of wire in the stator are insulated from the frame of the motorcycle, from the engine of the motorcycle, because the engine and the frame are all connected to the negative terminal of the battery. So if we got a reading there, if we got a beep, then that would be a bad sign, and again it would indicate that our stator is bad. So this is all indicating good. This indicates that our stator is good. So if we have problems now with our charging system of our motorcycle, we've checked the connections to the battery, we've checked the wiring in the wiring harness is all good. We've now checked that the stator is all good. Then it would indicate that the culprit is now the regulator rectifier. So we can run some tests to be sure that the regulator rectifier, before we go and spend a couple of €100 on a new regulator rectifier, let's run some tests to be sure that the regulator rectifier is actually the problem. So I've removed the regulator rectifier from the motorcycle, and that's going to allow me run some tests on the regulator rectifier using the multimeter. Now, I know from running tests on the connection that goes into the wiring loom that the that the 3 pins on the left hand side are connected into the 3 wires that feed into the stator. So the charge from the stator, the negative charge, should be feeding in through these 3 pins on the left hand side. And I know that the pin on the bottom right hand side is connected to the wire that feeds to the earth, or to the negative terminal of the battery. So we know that the negative charge coming from the stator flows in through these 3 pins on the left hand side, and it should then feed to the negative terminal of the battery to recharge the battery. And also we know that the pin on the top right hand side is connected to the positive terminal of the battery. Now we can turn on our multimeter and we can set it to read continuity. And I want to check that charge, or that we have continuity in the circuits that I just discussed there. And because the regulator rectifier acts as a diode, we know that we should have no continuity when we switch the leads around. So we should have continuity in the circuits that I just described, but when I switch the leads around, we should see that there is no continuity in that charge should not be able to flow in the opposite direction. So let's take our regulator rectifier. As you can see here on this particular multimeter, a reading of 1 indicates that there is no continuity, or there is a break in the circuit and charge cannot flow. If I get a perfect circuit, we get a reading of 0, 0, 0. So that would indicate that charge can flow in that circuit. And any reading above that indicates that there is resistance in the circuit. So a reading of a 100 or 200 or 300 indicates that there is resistance in the circuit, but charge can still flow, but at a reduced rate. So charge indicated by the black lead should be flowing in through the pin on the left hand side. So let's touch off one of the pins, and that charge should be flowing out through the bottom left hand pin. So let's test that. Looking at the multimeter, we see we get a reading of 595. Let's move the black lead to the next pin on the left hand side. We get a reading of 592. And then the next pin, we get 591. So that's, do that again, 595, 592. We get a good connection here. And 591. So that indicates the charge can flow in through the 3 pins on the left hand side from the stator, and it can then feed to the negative terminal of the battery. Now if we switch the leads around, we want to see, can charge flow from the negative terminal of the battery back to the stator. Sorry, I didn't switch them around. Switch them, the red connected to the pins from the stator, and the black from the negative terminal to the negative terminal of the battery, or the pin coming from the negative terminal of the battery. So we're getting a reading of 1 that indicates that there is infinite resistance. Next pin, stator pin, we're getting an infinite resistance of 1. And then on the next one, the third one, we're getting a reading of 1 as well. So that indicates the charge cannot flow from the negative terminal of the battery back to the stator, and that's what we want to see. That means that the diodes are working as they should, that the circuits are working as should, as they should, and that the circuits, the charge coming in through the 3 pins in the stator, that the resistance measurements are about the same. So that all looks good. Now let's look at charge coming in from the stator and going to the positive terminal of the battery through this pin on the top right hand side. So let's connect to that pin top right hand side with the red lead from the multimeter, and then the black lead indicating charge flowing in from the stator on the 3 pins. Go through them one by one. So there's one pin, it's given a reading of 1, so it's infinite resistance. Next pin, reading of 1, infinite resistance. The next pin is given a reading of 1, so it's infinite resistance. So that indicates the charge cannot flow in from the stator to the positive terminal of the battery. And again, that's what we would expect. If charge were flowing in from the stator to the positive terminal of the battery, that would cause the battery to discharge and lose its charge, and our battery would go flat. Okay, so I've switched the leads around from the multimeter. So I'm going to connect the black lead, which would indicate the possibility of charge flowing from the positive terminal of the battery to the back to the stator, or in through the pins that feed in from the stator. And we're getting readings again of 587, 586, 595 and 603. So again, that indicates that the diodes are doing their job, that they're allowing charge to flow in one direction but not in the other direction, and that the 3 readings are quite close together. So that's what we would expect. So this indicates that this regulator rectifier is working as it should. If your regulator rectifier will obviously have its own particular readings. It might be 800, it might be around 400, I'm not sure. But your own regulator rectifier, per the service manual, will have its own readings for resistance, which you can measure and check against the specifications in the service manual. But what's more important is that the diodes are working. Okay, so we are noticing that charge cannot flow in one direction, but it can flow in the other. We're noticing that we're getting readings that are in line with each other for resistance. So everything is working as it should. Now, then the third test that I want to do is I want to check, can charge flow from the positive terminal of the battery to the negative terminal of the battery through the regulator rectifier. So I connect the black pin to the black lead to the pin that's connected to the positive terminal of the battery, and I connect the red lead of the multimeter to the pin connected to the earth terminal of the battery, or to the negative terminal of the battery. And this is giving quite a high reading for resistance. It's giving 1314, so it's over double what the reading we were getting in the other readings I was doing. But it does indicate, although there is resistance, that current can flow from the positive terminal of the battery to the negative terminal of the battery through that circuit of the regulator rectifier. Now let's switch the leads around. Can charge flow from the negative terminal of the battery through the regulator rectifier and then onto the positive terminal of the battery? Now we're getting a reading here of 1, which indicates that there is infinite resistance. The infinite resistance means that the regulator rectifier is not draining current or draining charge from the battery. And that's again what we would like to see. So these are the readings. These readings that I am getting are consistent with a good, healthy regulator rectifier.